usual links. Usual thing to say, sponsor. If you do, well, hang on, I'm getting ahead of myself. Raffinelli, thank you for doing that. Simon, thank you. And while we're on the thank yous, Barry's already, he couldn't make it tonight, but he did say that he'll be happy to do the videos. So again, thanks, Barry. They are being hosted on MicroPython's official YouTube account now, which is still very young, but it's getting bigger every time a month goes past. We put something on there, and there is now that playlist, so all the Melbourne MicroPython meetups will be going into there. Right, so PyConAU 2023. This was a slide I had last month with our. These are links to the entries in the program, which gives like a short description. But you can now get the links to the videos. I've also got my slides up there as well. I haven't got Damien's or Jim's yet, but I'll share them as soon as I can. Damien's Teams Microphone. What just triggered me to that? Let me go back. There was something I saw. Sponsorship information. So one of the things that Damien covered in his talk, which was it was more about sort of the social aspect of running a largish open source project. One of the things he was able to share was some of the sponsorship information from GitHub. So how much money comes in through the GitHub sponsorship channel. So yeah, we saw some good graphs on that kind of stuff. Downloads, like which of the ports are most popular and how they've grown over time. So it's really interesting charts that you managed to dig out of some of the data that we've collected about MicroPython. My talk was more about the kinds of things that I hear about why people say that they think they can't use MicroPython. So there's three main sort of topics. Those three topics are probably going to escape out of my brain, but I'll try. One of them was like low power usage. So you can't use MicroPython if you've got low power usage. You can't use MicroPython if you've got performance needs, and you can't use MicroPython if you're trying to do volume manufacturing. And so we looked at those in sort of objectively and just tried to see if there was what reality was. In all of them, I think, no spoilers, there's a germ of truth to all of them, but I don't think it's, I guess my argument was that the reality is not really as scary as what people think. So if you'd like to, if there's a half-hour video, you can learn more about it. And Jim's was more, I would call it MicroPython adjacent. So Jim's been looking at doing the MPy cross tool and publishing that through pip, which Andrew Leach has been doing. Jim's been looking at taking it over, but part of the difficulty is that with it's basically just it's a C compiler that converts Python code to MicroPython bytecode. That's all it does. The problem is it uses a lot of the C code that's built into MicroPython. It's the same compiling engine. And then there's a small little Python wrapper, which effectively just uses a subprocess to invoke the compiler. Now, when you publish that using pip, you've suddenly got something like 27 different packages, because you've got to support all the different platforms, the different compilers. So yeah, we had a look at Jim showed NumPy, and there's literally about 27 different packages. So the idea here is that that's a very difficult thing for a fairly small core team like MicroPython to do. So an alternative would be to build a WASM tool to do that. And so you would only need the one WASM tool, and you'd rely on WASM execution engine to run on many platforms. So Jim has been looking into that, and yeah, gave a pretty compelling talk about it. So it's a quick overview of the talks, but I'm sure if you're in the MicroPython space, you'll probably find these pretty interesting. If you are going to watch Jim's, you might want to also watch Katie Bell's. Katie's a wonderful developer in Sydney. She was also talking about WASM, and Katie and Jim have actually worked together in the past. And unbeknownst to them, they were scheduled back to back because they were both WASM talks. When they found that out, they actually collaborated a little bit and sort of made them more complementary than they would have otherwise been. So Katie's a great actually sort of primer into WASM and how WASI works. And then Jim's kind of gives you a practical example of how you can actually use WASM. So I just realized I've been talking for a couple of minutes on WASM. It's WebAssembly, in case you're not aware. It's a way to use take advantage of some of the performance improvements that of running things and targeting the browser. That's how it started. Not just a browser technology anymore. Much like Node, it's also crept into operating systems and execution engines. I will say no more. Go watch them. They're good. And Damien gives his apologies, but his family's taking him out to dinner tonight because it's his birthday. So happy birthday, Damien. Right, so the main thing I want to talk about was the sprint day. So I don't think you guys covered it before, but the way Pycon structures the Fridays are specialist tracks. There's 4 different topics with talks running in parallel for all those topics. I didn't actually get to go to that this year. Saturday, Sunday is the sort of the bulk of the talks, and including the lightning talks. Lightning talks are always good fun too. I'd suggest watching those if you want like small digestible things. They're as usual, are pretty good. But Monday and Tuesday are sprint days, is what they call. And what's a sprint day? Well, it's kind of whatever you want. They basically just ensure that there's enough room at the conference venue with some tables, power, and you kind of have at it. And the idea here is that you've got a lot of people converging on a single location, and so there's a lot of people with like interests that are similar. So you might as well get them together and do something if they've got the time. So quite a few people stay on and hack away at various things. And Andrew and I decided to host a MicroPython sprint. We decided to take the extra day. And it was good. We had a bunch of people sort of show up, and we actually got a bit done. So one of the first things to talk about is that there was a talk in the main body of Pycon where Bhavani Ravi she went through live coding, like how to write a unit testing library from scratch, and this kind of came out of the effort to she just had. It had piqued her curiosity. How would you go and write that? And she went having a look into PyTest, and there's 130 or 140,000 lines of code in PyTest. It is overwhelming, and I've done the same thing. Like, yeah, sure, PyTest is great. It's very popular. Let's try and port it to MicroPython. And you take a look, and it's like maybe we'll do that for another weekend. So Vani was trying to figure out how to do it, and so she kind of just did it from scratch and thought, okay, well, I need the assert style unit test concept. I'll implement that. And then she kind of just started chipping away at it. And before too long, she had fixtures and sort of all the main, all the guts of the features of PyTest, or the key features. PyTest adds a whole bunch of other things like a full extension system and all sorts of things. PyTest is a wonderful library. I understand why there's a lot of lines of code there, but the 200 odd lines of code that Bhavani's library own PyTest had was a much more digestible thing that we could pick up and use and get quite a lot of the benefits of PyTest in a similar sort of library. So when we were watching this, while we were watching this talk, Andrew and I were sitting next to each other, and there was like a couple of functions came up that we weren't sure MicroPython had, and sure enough, this underbar code, a dunder code method wasn't available in MicroPython. Turns out all the actual information is stored in the C structures in the background, so I just needed to expose a little bit of that. So Andrew's got Andrew worked on a ticket while we're at the sprint, and that is kind of that was the key missing feature of own PyTest. That we needed to run own PyTest. And so our goal here is to make own PyTest run directly in MicroPython with no changes to it, hopefully. The other small changes that we've got are around import lib. It uses a couple of methods there, which we probably should add to MicroPython import lib. But this was pretty cool. I'll stop talking on that. I just realized I'm talking for ages. Francis, the guy who's back we have here, Francis Dela Cruz, very cool name. It was his first day using MicroPython, and he was just an example of someone who had seen it, was interested, and thought he'd come along and try to contribute. And on his first day, he raised a PR, so that was fantastic. I pointed him in the direction of the relatively new platform library. There's a platform module in Python. We've ported some of that to MicroPython, but it was lacking documentation, and so he was good enough to put that together for us. So it's great to have those kinds of additions. I had a bit of a fun one. I tried out MicroPython on Linux, which is running on ESP32S3. So this happened over the last couple of months, I suppose. Some enterprising soul has figured out that they can get Linux running on one of these relatively powerful micros, ESP32S3. I think the minimum is around 8 meg of flash and I think 8 meg of RAM at the moment that's being supported. But sort of if you're in that ballpark of memory, there's a number of devices where there's already pre-built binaries you can grab. So I've been sort of following this via Rudy, who is popular and who publishes quite a lot on Twitter. And he's worked with Espressive a little bit. I don't think he works for Espressive, but he's Espressive adjacent. And Rudy had been asking me a few questions because he's also built MicroPython for Linux on the ESP32S3, but didn't have much peripheral support. And so he's kind of grafted on some. So he figured out how to do a few things, like in particular, there's an LED on this particular device we were using, which was the M5 Stack Core S3. And he figured out which registers to poke using the Linux proc commands. And he's wrapped that up in a method, which he's then calling through the MicroPython, through some MicroPython APIs. So what he would like would be like a machine module, which is implemented to twiddle various things on this device via the Linux methods. But it is pretty crazy seeing this thing boot in about 3 seconds to a full Linux prompt. Pretty amazing stuff. So I have a rough idea there of where I want to take that. We had a couple of beginners join as well. Most have sort of dabbled with MicroPython, but weren't that familiar with it. So upgrades to the latest, like one went from 1.11, which is getting pretty long in the tooth now, to 1.20. MP Remote, I'd sort of given a quick, just a single slide on how to use MP Remote mount in my talk, and that I guess that was a lot of people still hadn't seen MP Remote, and mount's pretty magical, I guess, the first time you see it. So a bunch of people that were using MP Remote were very impressed with it. Someone got like a hello world working on a TFT, so they could render just some text and some boxes onto the screen. And another one got AIO BLE running in a very, very simple way, but sort of scratched the surface. Last one to talk about, I guess, I'm not sure if did he make it in? Anyway, if Sean's there, he has bought a few of these Espa boards from Crowd Supply. And there was an old PR that, hey, there you are.
Yes, I am here.
Yeah, there was an old PR that the company had raised, PyConAU, and Damien had given some feedback, and they'd sort of been neglected since then. And Sean, do you want to talk a bit more about this? Or?
Yeah, I was just going to say, and also I think from having chatted to the guy, I suppose, through the comment on the pull request, I think the company is just the one guy, which is kind of neat. But he'd originally raised a sort of a larger pull request that made a few changes to the actual, needed to change a few C files in the MicroPython, I guess, source. But yeah, that's no longer necessary. It just works basically out of the box. Completely out of the box, just with a normal ESP32 build. And so, yeah, really the only thing now that I guess would be neat to have, although not completely necessary, but, still need to have, would be, just to do the pin aliases so that when you're using the board, you can refer to the pins by the name that's written on the silk screen rather than having to look up the pinout table to figure out which one is which. So, I suppose just started working on that. I've got it working as a build. I guess just got to follow up with Damien as to kind of how the best way to do that is, because I think you'd mentioned it last month, Matt, the pins CSV thing for the ESP32 is kind of new. So, I guess just need to figure out what the best way to handle that is. But, it looks good. And, the original maintainer, I don't even know. I think he was in Canada somewhere. I can't remember what time of day it was when I would have made my comment on this pull request from like a year and a half ago, but he responded within about 5 minutes or something like that. So yeah, definitely thumbs up to him for that. I don't even know what his actual name is. It was just a GitHub username. I suppose I should actually figure that out. But anyway, I'm very glad I bought them. If you're interested at all, yeah, ESP32 with PoE added to it, and there's still, originally it was a crowd supply, like crowdsourced project, but they're available just for general sale through Mouser, I believe. So yeah, they're quite a neat little board. No.
Cool. And one of the interesting things here was these mini modules that Espresso used to produce. When they first came out, these were a single core, and that was part of the issue with this PR at the start. The single core units weren't supported, and so they added support to it, which has since been upstreamed. But in the meantime, Espresso have now made all of these dual core, so that's not even necessary anymore. But it was interesting history trying to unravel what had happened here, because we couldn't figure out why they were unicore. Anyway, I think that was kind of all we had from the sprint day. Yeah, that was about it. It was good though, good turnout, and it was fun. If there's questions, we'll tackle them later. But CircuitPython Day was on the 18th. I wanted to do a little bit more, but it was just a hectic day because it was actually the start day of Pycon, and so just shout out to the CircuitPython folks, Adafruit, and all the people who work on that. Happy CircuitPython Day. They have that once a year on the 18th of August, and yeah, good to see that happen. That's what I've got for you for those. I did have a few tabs open up just from, that's what I do. The Memphis Python group. If this time zone works out well for you, it doesn't work out great for us, but it's already been passed. Hopefully they have a recording. I've reached out to the organizers, but yeah, they're doing a Internet of Things thing. What was this one about? I can't remember. I remember anything. Let's skip on. The Seed Studio one, they've some new hardware, so they've released a matrix LED board that's designed to fit into those YAOs. And this is a 6x10 RGB board. I haven't looked into it much more than that, but LED boards are always popular, so how about it? And another board for specifically designed around the RP2040 for model rocketry. And we've had a couple of people come through the group who've liked that kind of thing, so go check that out. Phil, who's we're talking about the Pymaroni graphics library. Phil's probably the main developer for that library. He's been working on vector graphics lately, and this is the clock that he's produced with it. Interestingly, here he's got anti-aliasing working as well, so this actually looks really smooth, especially when you compare it to like the non-anti-alias version. This might not be coming through very well, but this is all chunky and iffy, whereas this one looks nice and smooth. So I presume that'll be added to the rest of the graphics library. I'm not sure how it's going to be grafted on. AA is a bit, can be a bit tricky to get the API right. Inkplate we've focused on a couple of times in the past. This is another one they've released. Interestingly, this one has a limited production run. It seems like they've just gotten some e-ink devices from some company and are making a particular 3.8-inch device, presumably based on all their existing technology. If you're interested in that as a form factor, it might be useful. Looks quite high res. It's like 600 by 600. If that's right. Yeah, 600 by 600 3.8-inch display, which for an e-ink display is getting up there. It's pretty good. Shannon Russell, I hadn't come across Shannon before, but he's like, anyone who's going to put wheels and motors on a device that looks vaguely like a moving object and slaps plywood on the top is okay with me. So he's using his cell phone to program this or to control it over Bluetooth. This is fantastic. NXP, this was an interesting announcement to me because I am ever frustrated at microchip manufacturers who give you the worst development tools I can possibly imagine. So NXP used to offer, I think it was an Eclipse-based system from memory. And now they've gotten in behind Visual Studio. So they've basically made it all open source. And they've tied it into what looks like a pretty good extension to Visual Studio to program the devices. So not for use for MicroPython directly, but if you're interested in doing embedded development or working on the C implementations of MicroPython, Robert, for example, you're the primary maintainer of the NXP side of things, so perhaps this is of interest to you. In the latest talk, latest one might be a new one since, but in a recent Talk Python to Me podcast with Michael Kennedy as the host, he interviewed the PyScript folks again, and they talked quite a lot about MicroPython with using and how it's being used by PyScript. It will be the default Python implementation, which is pretty interesting. And yeah, it looks like it's coming along quite nicely. Worth a listen. I haven't really dug into this one yet, but this is the T-Watch. Now they've actually come out with a few different versions of this. I don't think we've covered this one before. I think it's new. It's an S3 based one. They're using the same housing, so it's actually a bit difficult to tell them apart. But the difference is here that I'm pretty sure we haven't covered before is it's S3 and it's got LoRa. So if that combination of stuff is, I'm pretty sure it has LoRa. Maybe I mentioned, no, it does LoRa. Cool. And it does support the whole swathe of frequencies that you need to for global use. So yeah, if you're interested, check it out. I just loved this quote because I don't like Arduino. It's not that I don't like Arduino, it's just that I think MicroPython's better. Yep. OLMX launched a board. It's another ESP32S3. Can power a LiPo. It looks decent. Got a bunch of people interested because OLMX tends to support their boards pretty well. CNX reported on an industrial IoT controller based on an ESP32, but it's in a rugged kind of case. I don't know if MicroPython supports official, but if not, we will build a board definition for it. This is an easy thing to do. John, I had a talk with John a while ago. We might get him on and having maybe he'll do a demo for us at some point, but he's got an EMLearn library, which is a C library to work with machine learning models, and it can work with, I think I'm using the wrong words, I can't remember what the implementation is, but it can take models built with scikit-learn and make it easy to use them from Python and MicroPython now. So he's got MicroPython bindings for the EMLearn library, which is really cool. And so he's got some examples of these. And if you've got some nice sort of self-contained demo ideas about how do you learn machine learning here, particularly around like decision trees or any form of machine learning model, really, especially it can be done in scikit-learn, reach out to me or to John, and he's looking for like good examples to package together to make it easy to sort of get started with this stuff. Well worth a look if you're into that space. And Sion released his Nano S3, which has been sort of in development for a little while, but it's a tiny, it looks giant on this screen, this photo, but it's actually a tiny little ESP32 S3 that can be, it's castellated, so you can pop it down to your own board really easily. That was it. The only other thing I had was that, Simon, I know you've got flip dot displays or flip chart displays. This was a particularly neat one, neat example of some water.
Yeah, those come from a company called Alpha Zeta. So I put this one on in the background. It's a bit noisy and it has this moire effect on camera, which is annoying. But
that still looks beautiful. Yeah.
The cool thing about those ones is they also do mechanical 7-segment displays that can run at 60 frames a second. So you can basically translate video onto them, which is pretty amazing. But I daren't ask them how much they cost.
Yeah.
Like for scale, this was like £112 delivered off of eBay, and it's big and heavy. So like about a third of that was the shipping.
Yep. I'm still trying to find one. I've been keeping an eye on eBay for a long time. It's just, yeah, in short supply out here. But that's about all I had, just sort of quick off the cuff kind of stuff. So I should probably leave it there. Were there any questions or comments, or did I miss anything? Oh, there was stuff in the chat. Had we not covered Damien on Embedded FM? I might not have covered that last month. Yeah, absolutely. Go listen to Damien on Embedded FM. Yeah.
Got a question in CCHS. You might have to come around here because it's on my laptop.
That display you're showing,
Yep.
Is that a sort of flip type display, a mechanical flip display, is it?
The one with the water simulation?
Yeah.
Yeah, it's a flip dot display, that one. Yeah.
Okay. And what did you say the rate was you could refresh at? 60 hertz, something like that?
So Simon was referring to a slightly different display, but made by the same company.
Those ones very, very fast. So this one, what you can't see is it only refreshes in one whole frame left to right. You can't control individual pixels. But I convinced Paul at Pymaroni to go buy a couple of these, and he's looking at bypassing the controller in the back of these so that you can work at a lower level protocol than the really weird binary protocol that this one uses. So hopefully you will be able to do arbitrary updates and speed it up. This one does 2 frames per second, otherwise it just starts dropping them really badly.
Yeah, I have an application I want to display that I can, a mechanical display that I can refresh at, probably 10 milliseconds. 100 milliseconds. Okay, so that's why I was interested in the concept. So
yeah, right. I've chucked the link in the chat.
right.
Yeah, you might want to check it out.
I will. Okay, thank you.
Cool. And yeah, Ben, I remember the days of where we had small numbers of megabytes of RAM and trying to run Linux, but it still seems we've come full circle, right? So yeah.
I still want a flip dot display for my house, a massive square one, because I want to have it be able to dynamically configure QR codes to display on my wall. I figure that's the neatest way of doing it. But when I tried to look up displays that would do that, God, they're horrifically expensive.
They're expensive.
But I love the idea of sitting there like passively as as art nominally,
Yeah.
and then you want to connect to the Wi-Fi, and just like.
I saw a fun project on Twitter with, the what you call it, the letters that flop over, and you have the whole alphabet in there. There's a name for that, which escapes me right now. But like the sort of Rolodex of things. Somebody had got 6 of those, and what it was doing was it had got every word in English that has 6 letters and the minimum difference between them, and it was just updating periodically with like the minimum change. Just the nice, like people do the slow e-ink displays, like that sort of thing.
Like a blue to
Yeah, this displays are pretty amazing. Very cool.
Cool. We better get started on putting Redis on all of the devices that we have here. We need every single one of Matt's device that we have here running Redis by the end of the time.
I'm trying to get them all back, and they'll all have Pico Redis installed on them.
Exactly.
The person sensor's interesting because the first commercial thing that I used Redis streams for with a customer was they were sending stills from a video in a sort of public space that they own.
Right.
And what they wanted to know was basically how many people are in this still, but capture it and process it in a sort of frame buffer type way. So almost that, but not quite.
The person sense is great. It's especially intriguing because it's so cheap. It's like $10 US, which, yeah, wonderful. And it's pretty good. Like, I mean, that quickly cobbled together demo that the guys put together was pretty compelling. Like it renders a blob roughly where you expect to see someone's face. That's pretty cool.
It can do nifty
that
things
is
too. You can get it to register people, so you can say like, "Oh, the face you're currently looking at is me." So then it'll tell you, "Oh, hey, I noticed ID 1." So then you can set up like, if you were really spicy, you could set it up so that it would unlock your front door when you walk up to it. Definitely an undefeatable technology.
Yeah, I'm interested in all of this sort of stuff. I think I said to Matt, I actually used to live in New Zealand and work for customs on the SmartGate system that you have down there.
Yeah, I mean, they do go out of their way to say that it's not for that purpose. But it's still pretty interesting. Like it also gives you like a percentage of how close it thinks it is to the person that it thinks it is. So it's pretty nice. There's some other thing that I was going to share. Something we should probably share is that while we're on the topic of ESP32, the board variance has been introduced. And there's already been a few people complaining about it because it's on the nightlies, but it does change the way that the builds work. And Jim's trying to consolidate some of the builds. This feature has come from, well, the Unix port, the STM32, and the RP2040 ports all have board variants. And the idea is that you can sometimes purchase a board, but it comes in a number of different SKUs or configurations. Like the obvious ones, like there's an RP2040 board called the WaveShare, and that the only different, you can buy it in 4 different flavors, and those flavors just differ on the amount of flash that's connected. But the other one's the Espressif DevKit C, which also comes in like 8 or 9 different flavors. So the idea here is you would say, my board, when you build, you go board equals DevKit C, board variant equals the octal flash quad SPI RAM or whatever it happens to be. So the generic builds are also in this format now. So they've gone to like generic S3 and then SPI flash and so on. So this will all be published in pretty clearly in the release notes when we get there, but it has caught a few people off guard. So and they've rightly been a bit upset about it when things have changed so dramatically. But yeah, not sure how far away we are from the release. There's only one active ticket gating it, but yeah, I know Damien's been very busy, so with PyCon at least.